Hello, it's Mr. White. I'm reading from the 7th grade science textbook. We are on Chapter 3, Lesson 2, Classifying Life. My Planet Diary, Birds of a Feather. When people first began to travel in airplanes, birds often caused crashes. In 1960, 62 people were killed when birds flew into an airplane's engine. Something had to be done, but no one knew what kinds of birds were causing the crashes. Usually only a tiny, burnt piece of feather remained. Engineers didn't know how big or heavy the birds were, so they couldn't design planes to keep birds out of the engines. Then a scientist named Roxy Laybourne invented a way to classify birds using a tiny piece of feather. She identified the birds from many crashes. Her work helped engineers design engines to reduce bird collisions. She also helped develop bird management programs for major airports. Roxy's work has saved passengers' lives. Why do biologists classify organisms? So far, scientists have identified more than 1 million kinds of organisms on Earth. That's a large number, and it keeps growing as scientists discover new organisms. Imagine how difficult it would be to find information about one particular organism if you have no idea even where to begin. It would be a lot easier if similar organisms were placed into groups. Organizing living things into groups is exactly what biologists have done. Biologists group organisms based on similarities, just as a grocer groups milk with dairy products and tomatoes with other produce. Classification is the process of grouping things based on their similarities, as shown in Figure 1. Biologists use classification to organize living things into groups so that the organisms are easier to study. The scientific study of how organisms are classified is called taxonomy. Taxonomy is useful because once an organism is classified, a scientist knows a lot of information about that organism. For example, if you know that a crow is classified as a bird, then you know that a crow has wings, feathers, and a beak. The naming system of Linnaeus. Taxonomy also involves naming organisms. In the 1730s, the Swedish botanist Carolus Linnaeus devised a system of naming organisms that is still used today. Linnaeus placed organisms in groups based on their observable features. Each organism was given a unique, two-part scientific name. This system is called binomial nomenclature. Binomial means two names, genus and species. The first word in an organism's scientific name is its genus. A genus is a classification grouping that contains similar, closely related organisms. As shown in Figure 2, pumas, house cats, and marbled cats are all classified in the same genus, Felis. Organisms that are classified in the genus Felis share characteristics such as sharp, retractable claws and behaviors such as hunting other animals. The second word in a scientific name often describes a distinctive feature of an organism, such as where it lives or its appearance. Together, the two words form a scientific name of a unique kind of organism. A species is a group of similar organisms that can mate with each other and produce offspring that can also mate and reproduce. Using binomial nomenclature. A complete scientific name is written in italics. Only the first letter of the first word in the scientific name is capitalized. Notice that scientific names contain Latin words. Linnaeus used Latin words in his naming system because Latin was the language that scientists used during that time. Binomial nomenclature makes it easy for scientists to communicate about an organism because everyone uses the same scientific name for the same organism. Using different names or common names for the same organism can get very confusing, as Figure 3 describes. What are the levels of classification? The classification system that scientists use today is based on the contributions of Linnaeus. But today's classification system uses a series of many levels to classify organisms. To help you understand the levels of classification, imagine a room filled with everybody who lives in your state. First, all of the people who live in your town raise their hands. Then those who live in your neighborhood raise their hands. Then those who live on your street raise their hands. Finally, those who live in your house raise their hands. Each time, fewer people raise their hands. The more levels you share with others, the more you have in common with them. the major levels of classification. Of course, organisms are not grouped by where they live, but by their shared characteristics. Most biologists today classify organisms into levels shown in Figure 4. First, an organism is placed in a broad group, which in turn is divided into more specific groups. A domain is the broadest level of organization. Within a domain, there are kingdoms. Within kingdoms, there are phyla. Within phyla, there are classes. Within classes are orders. Within orders are families. Each family contains one or more genera. Finally, each genus contains one or more species. The more classification levels two organisms share, the more characteristics they have in common, and the more closely related they are. How are taxonomic keys useful? Why should you care about taxonomy? Suppose that you are watching television and feel something tickling your foot. Startled, you look down and see a tiny creature crawling across your toes. Although it's only the size of a small melon seed, you don't like the looks of its two claws waving at you. Then, in a flash, it's gone. How could you find out what that creature was? You could use a field guide. Field guides are books with illustrations that highlight differences between similar-looking organisms. You could also use a taxonomic key. Taxonomic keys are useful tools that help determine the identity of organisms. A taxonomic key consists of a series of paired statements that describe the various physical characteristics of different organisms. The taxonomic key shown in Figure 5 can help you identify the mysterious organism.